Hello everyone, welcome to Engineering Archives. Let us look at practice problem number 4 for this chapter, Cartesian vectors. So this problem says, determine the magnitude and direction of the resultant force acting on the pipe assembly. So they have given us two forces and they want us to find the magnitude of the resultant force. So we will need to somehow add these two forces. And then they also want us to find the direction. So notice that this question is in 3D, which means three-dimensional, or in three different set of axes, and that means that we will have to give them three different angles from the x, y, and the z axis. So let's get started. So in order to add these two forces, we will need to add their respective components in each direction, the x, the y, and the z direction. And to do that, we will first need to find the components along each direction. So let's write these two vectors first in their Cartesian forms so that we can add them, add their components in each direction. So let's start with F1. Notice that F1 lies in the xz plane, which is this plane. And that means that we're only going to have components along these two axes. So to find its component along the x-axis, we will need this angle right here. And we can find this angle using this triangle that they have provided us with. So using the tan identity, tan of theta, we get theta equals to 36.87. So the component of F1 along the x direction is going to be equal to 600 of 36.87. This is equal to 480 pounds. Now, component along the z-axis, we can simply do 600 sine of 36.87, and we get 360 pounds. Moving on to the force F2. They have given us two angles that we need to find the components along the x and the z direction, but they haven't provided us with the angle that we need to find its component along the y-axis. But that's okay, we can use the resultant force formula to find that component. So let's find its component along the x direction first. So its component along the x direction is going to be equal to 400 cos of 60 degrees. And this is equal to 200 pounds. Its component along the z-axis is going to be equal to 400 cos of 120 degrees. And this is equal to negative 200. Notice that the negative sign makes sense because the force F2 is directed towards the negative z direction. Lastly, we need to find the component along the y-axis, but since we don't have this angle, we will use the resultant force formula to find its component along the y-axis. And that formula is R equals to, or resultant force equals to the sum of the squares of each component square root. Substituting in the values and solving for the y component, we get, first we square both sides, then we subtract the x component and the y component from both sides, and lastly we take square root of both sides. And the answer that we get for Fy is 2 oops is equal to 283 pounds. Now that we have the components for each of the forces along all directions, we can simply write them as in their Cartesian form, and then we can add them. So writing F1 in its Cartesian form, we have 480i plus 360k, while F2 will be equal to 200i plus 283j minus 200k. And now we can just add these two. So the resultant force F is going to be 400 plus 200i plus 283j plus 360 minus 200. And this will be equal to, oops, this is 480, not 400. So this is going to be equal to 680i plus 283j. It's 160k. But they want us to find the magnitude of the resultant force. So we will use the resultant force formula to find its magnitude. So the resultant force, or the magnitude of the resultant force, is going to be equal to sum of the square of the resultant force square root. And the value that we get for the resultant force is 754 pounds. Now to find the angles between the resultant force vector and each of the x, y, and z axes, we will use the formula that we discussed in the previous videos, which is cos an angle x, y, or z is equal to the component of the force along that axis divided by the magnitude of that vector. So for the angle between the resultant force vector and the x-axis, we can do cos of theta x equal to the component of the resultant force along the x-axis divided by its magnitude. Its magnitude is 754 pounds, while its component along the x-axis is equal to 680 pounds. So 680. Solve them for theta x, we get theta x is equal to 25.5 degrees. Doing the same procedure for theta y, we get its component along the y-axis, which is 283 pounds, divided by its magnitude, which is 754 pounds, and the value that we get for theta y is equal to 67.8 degrees. And lastly, for theta z, we get its component along the z-axis divided by its total magnitude, and theta z is equal to 77.7 degrees. So this was the lengthy but easy procedure for this question. Thank you very much. See you in the next video.